what we mean by the product rule is you have some function that's made up of two functions multiplied together. An example might be x squared times cosine of x. That would be a product. Or the square root of x times some polynomial. That would be a product. So if we start our proofs off the way we've been doing them, okay, I'm picking two values of x, but I'm imagining continuing to pick values of x as they get closer and closer to some value. And so the limit of h of x minus h of a over x minus a is again representing slope. And I'm going to replace h of x with the idea of it being a product. And like the ones we've done all this evening, every one we've done this evening, we've kind of gotten hung up at that stage that whereas Tuesday night we were able to factor and get somewhere. Well, all the ones tonight required some special algebra trick. So the special algebra trick we're going to use here is we're going to add and subtract the same thing, but so it's not going to change the value, but it's going to give me a form that I can manipulate like I did in all the other proofs. But I'm going to add and subtract the new thing in the middle, okay? And so I'm going to subtract f of a times g of x, and then I'm going to add that same expression. Okay, and I have to keep walking around my desk here. Oh shoot, this is going to be a bad place to have to stand. Okay, so I'm going to add f of a times g of x. Right, so I added and subtracted the same expression, so this new expression is still equivalent to the one we started with, but I'm going to be able to break it up here and whittle it down to some rule that we'll be able to follow. Okay, so the limit of a sum is the same as the sum on the limit, so I'm able to break it where there's a sum. Notice the x minus a had to go underneath both of these because I'm adding, I'm not multiplying like I was in the cosine and sine problems. So these two fractions have to add together to give me that fraction, so their common denominators need, so the x minus a is the common denominator for the two. Okay, so again, what I did is I broke it here, and I took the limit of this plus the limit of that, and the two added together is equal to that one we have up there. So what I want to do next is notice that I can factor something out here. What can be factored? G of x can be factored. This one, what can be factored? The f of a. just so that everything looks exactly like it's supposed to. I have a product here, so I can once again break it up. A product, a limit of a product is the same as the product of the limits. Okay, so on this one, there's a product here, so I'm rewriting it as the limit of the first factor times the limit of the second factor. Notice now the x minus a is only under that one term, because I'm multiplying. So this times that is still my numerator, 1 times x minus a is still my denominator. And then I did the same thing with that other one. And the reason why I broke it up like that is because this and this are familiar forms. Every single proof we've done since Tuesday has started off that same way. I've written that exact same thing down. So this is representing the derivative of the function f at a, and this is representing the derivative of the function g at a, and then as x goes to a, this is going to turn into g of a, and as x goes to a, this is going to turn into f of a. So that is the product rule. There's a verbal form of it that really people use to kind of help remember what they're supposed to be doing, but if you step back, first notice that you've got a sum, and what you're adding is the one function times the derivative of the other one. And then you reverse. And which one you really do first doesn't matter because you're adding, and the order that you add doesn't matter, okay? But people tend to learn this as they'll say first times the derivative of the second plus the second times the derivative of the first. And basically, again, what you're noticing is you leave one alone, and then you take the derivative of the other one, and you multiply them together. And then you add the reverse. So the other one whose derivative got taken gets left alone, and then you take the derivative of the one you left alone in the first term. But people usually, write it and say it as first times derivative of the second plus the second times derivative of the first. Okay, so we don't have a final formula like sine of x or cosine of x because, the product could be made up of anything. So the best we could do is, come up with that pattern. If you have a quotient, a pattern comes up, again, the proof is very similar to the one we just did. I'm just not going to drag through the quotient rule. I'm sure your book has it all worked out. So instead, I'm going to just kind of focus on the rules. So what we just got finished with is the product rule. And if my function is a product, then the derivative is equal to one function left alone times the derivative of the second, and then you reverse course. Okay, so that's our product rule.